Alright, for this question, a girl throws a tennis ball as hard as she can off the top of the building. Ignore the effects of air resistance in answering the following questions. The ball is thrown horizontally with a speed of 70 kilometers per hour, so just be aware that's a horizontal velocity. And the time is 4 seconds. Calculate the height. Alright, so let's write some facts down. Now, height is a vertical component, so we only look at vertical components for this one. My time is 4 seconds. My acceleration is obviously going to be 9.8 meters per second. Now be careful when you write your velocity. You would think it's 70 kilometers per hour, but remember that's a horizontal component. Initially, there's actually no vertical component, so it's actually 0. My v final should technically be 0 as well. So it doesn't matter which equation you use because you technically have all facts as long as you're incorporating s. Well, to make it easy, I'm just going to write the equation that has s equals. So just so I don't have to rearrange anything, chuck it in. Well, that goes away because it's 0. Half a is negative 9.8. 4 squared. So that is 78.4 meters. So you get negative answer, and that just means that it goes down downwards at 78.4 meters. But technically, therefore, height of building, you can conclude it. Height of building is just the positive of that, 78.4 meters. Alright, how far from the base of the building does the ball land? So, how far from the base? Oh, that's not a highlighter. Oh, what's going on? So now that, hopefully you understand that it's a horizontal component. So that is what we're going to look at now. So some facts are remember this fact 70 kilometers per hour, that's the horizontal velocity, so I can use that as my initial velocity now. VOH is 70 kilometers per hour. And if I divide that by 3.6, I should be able to change it into meters per second. 19.4 meters per second. My S is the question mark. My time, how long does it travel for? 4 seconds. The equation I use, simply V equals S over T. Right, you can only really use the one equation for that one, or horizontal component. So 19.4 equals S over 4. So therefore my S is going to be 19.4 times 4, which is going to be 77.6 meters. Alright, determine the velocity of the ball as it hits the ground. So, now, let's have a look. So this kind of, you have to figure out the vertical and the horizontal component, but what we do know about the horizontal component, that it's constant wherever it is. So we should know that constant was 19.6, I think it was, 19.4. 19.4. Now what we have to find is the vertical component. So we'll have to figure that one out. Obviously we know some facts. 9.8. So we write all the facts that we know. My time is 4 seconds. My, what else do I know? My V should be, V0 should be 0. Let's use this fact. Alright, so what can I use? 1, 2, 3, 4 facts that I'm going to use. V equals V0 plus AT. My V equals V0, 0. Take 9. Oh, I didn't really need that bracket, did I? 4, which is going to be a negative velocity at 39.2. So now what we can do is draw a vector diagram. So I've got my V horizontal at 19.4. I've got my negative, so that's going downwards, 39.2. So my resultant vector looks something like this. So I have to figure out my velocity. So my x is just using Pythag, square roots of the square of those numbers. It's a right angle triangle. There we go. So that should be 43.7 meters per second. So that is my velocity. Now I've got to figure out the angle. Remember, that's quite important as well. So let's find that angle. So my tan theta is opposite over hypotenuse. So now to figure out that angle, you go inverse tan. And you just chuck this in the calculator. Right, make sure your calculator is in degrees, not radians. 63.7 should be your answer. So let's conclude our answer. So therefore, my velocity is 43.7 meters per second. 63.7 degrees. Now, when we do equations of motion, you can write below or above horizontal, basically. Below horizontal, because that's the horizontal line and it's below it. Horizontal. That's it. Done. D. The girl enters a competition which requires the ball to land at least 100 meters from the base of the cliff. Determine the initial velocity of the ball required to do this. Still thrown horizontally. Is it worth her while entering the competition? Okay. So basically we want to get my range. So this is horizontal component. Just keep that in mind. So basically we want our S to be at least 100. So for her to be, in the competition, has to be at least 100 meters. My time is say 4 seconds. So my velocity is what we're trying to find. Okay, so my equation, wrong equation, V equals S over T. So you should sub that value in. So 25 meters per second is what we want her to be minimum, which, let's have a look. What was hers? Hers, we calculated it to be 19.4, so she's not quite there. She's, she's not going fast enough, so she shouldn't really bother entering the competition. So my answer is no. So that's what you would conclude. No, as she throws approximately 20 meters per second. The girl friends tell her that she could win the competition if she throws the ball at an angle slightly above the horizontal. Explain why her friend is right. I'll get you to read the solution in E. It explains it in detail, but basically changing the angle of your throw affects the range of your throw, but we will look into that further. I think we definitely look at it in year 12. I'm not really sure about year 11. It's not necessary, but give it a read. And that's it for question 1.